We know that for some common angles that we use, there are exact values of our sine, cosine, and tangent ratios. And they're much more convenient to use in a lot of cases than the decimal approximations you get when you put, say, tan 60 degrees into your calculator. And so we can determine those exact values using what we call the special triangles. The special triangles contain those angles, 30, 60, and 45 degrees. And we have two triangles, a 30, 60, 90, and a 45, 45, and 90. Now we can use those triangles to write the sine, cosine, and tangent of each of these angles because we know the ratios for the right angle triangles. First, we need to find the third side length of each of those triangles, and we can do that using Pythagoras' theorem. So on the first triangle, we'll find side A. We'll label our sides A, B, and C. And we can use a rearranged version of that formula for finding a short side. A squared is C squared minus B squared. Or A squared is 2 squared minus 1 squared. A squared is 2 times 2 is 4 minus 1 equals 3. We can square root both sides and we get A equals the square root of 3. And we want to leave that as a surd because that's the exact values that we're looking for as opposed to the decimal approximations. And now we can write that on our first special triangle. The third side is square root of 3. We can also determine the third side of the 45, 45, 90 triangle, once again using Pythagoras' theorem. This time we're finding the hypotenuse, C, so we use Pythagoras' theorem. C squared is A squared plus B squared. C squared is 1 squared plus 1 squared. Well, 1 squared is 1, 1 squared is 1. So C squared equals 2. We take the square root of both sides and we're left with C equals square root 2, once again left as a surd. And we can add that value to our 45, 45, 90 triangle for the hypotenuse. Now that we know all three values, we can write the sine, cosine, and tangent ratios for each of the angles. Let's start with sine of 30. So looking at our 30-degree angle, we know sine from the ratios I've got on the left-hand side here is opposite over hypotenuse. The opposite here is 1 and the hypotenuse is 2. So sine 30 is 1 over 2 or 1 half. Our next angle is cosine of 30. Once again, looking at the 30-degree angle, cosine we can see is adjacent over hypotenuse, or in this case, square root 3 over 2. Our adjacent was square root 3 and our hypotenuse was 2. And finally, tangent of 30, which is opposite over adjacent. Our opposite is 1 over the adjacent side is square root 3. Now, the problem with leaving tan 30 as 1 over square root 3 is it has an irrational denominator. Let's rationalize that denominator and put it in our preferred format. So to do that, we multiply by square root 3, top and bottom of our fraction. And we're left with 1 times root 3 is root 3 over 3. And that's 1 over root 3, but written with a rational denominator. The next angle is sine 45. So we need to look at our second special triangle with the 45-degree angle. You can choose either of the two 45-degree angles for this calculation of ratios. So looking at sine, once again, is opposite over hypotenuse. Our opposite is 1 over the hypotenuse, opposite and hypotenuse, which is square root of 2. And once again, we've got that irrational denominator. So we need to rationalize the denominator. We multiply by square root 2 over square root 2. Top and bottom are multiplied by square root 2, which gives us root 2 over 2, a rationalized surd. Our next angle is cosine of 45. Cosine is adjacent over hypotenuse, which is 1 over root 2. And once again, we've got that irrational denominator. We just rationalize this for sine of 45, and so we can write that straight away as square root 2 over 2 because we know what that will equal. And our tangent ratio is opposite over adjacent, which in this case is 1 over 1, or just 1. Our final angle we're looking at, our final common angle, is 60 degrees. So back to our first special triangle. Our sine ratio is opposite over hypotenuse, or square root 3 over 2. Cosine of our angle is adjacent over hypotenuse, 1 over 2. And the tangent of our angle is opposite over adjacent. Our opposite is square root 3 over our adjacent is 1, or just square root of 3. And so there we have exact values for common angles in the first quadrant of the unit circle, or the trig ratios for angles between 0 and 90 degrees that are quite common.